Good morning, everyone, and welcome to today's webinar, Electrical Safety Program and NFPA 70E 2018 and CSA Z462 2018 Changes and Updates. This is part one of a two-webinar series. There will be a future date scheduled for part two, which will review the risk assessment procedure requirements in NFPA 70 and CSA Z462. So welcome to today's webinar. Please realize that in the control panel there's two areas I'd like to bring your attention: the questions section and the handout section. Underneath the handout section, there is a document, CSA Z462 differences document, and please download that and reference that after the webinar. Again, welcome to today's webinar. My name is Terry Becker. I'm a certified electrical safety compliance professional. I'm an IEEE Senior Member, and I'm also the Senior Vice President of Electrical Safety at Danatec Educational Services. I'm involved in several of the standards. So obviously Z462 here in Canada. I'm a voting member, also a working group leader on Z462. I also attend all of the NFPA 70 Tech Committee meetings and participate in the annexes working group specifically, but also participate in several of the other working groups when I do attend the NFPA 70 Tech Committee meetings. I'm an IEEE 1584 Tech Meeting voting member. Here in Canada, I'm an associate member on the CSA Z463 guideline for maintenance of electrical systems. I'm also the subject matter expert at Danatec for our electrical safety audit process, our electrical safety program, a licensed product in a box, and the related consulting services, the low and high voltage arc flash and shock training solutions, instructor-led and blended training, as well as the electrical safety training system, e-learning for electrical workers and non-electrical workers that we have available at Danatec. With respect to Danatec, just a word of note that I was the previous owner and president of ESPS Electrical Safety Program Solutions, Inc. Effective August 1st, 2017, I sold ESPS to Danatec Educational Services Ltd, based out of Calgary, Alberta. And you can check our website, danatec.com, for more information with respect to Danatec and the electrical safety services provided. So again, welcome to today's webinar. Please download the differences document, as I mentioned, in the GoToWebinar control panel. I'm going to start the webinar by talking about the Danatec Electrical Safety Program and the workflow process flow chart and how I frame the effective management of arc flash and shock hazards against energized electrical work tasks. I will then talk about the electrical safety program requirements in NFPA 70 Article 110.1 or CSA Z462 Clause 4.1.6. So as I've been working through managing arc flash and shock hazards over the last 12 years, right from the beginning, it was apparent to me that it's a work task issue. It's the worker that receives those work tasks and has to execute them. And that's what the workflow process flowchart that I'm going to show you really indicates in a visual aid: is this worker receives this work, and how do they, from an administrative process related to the occupational health and safety management system the employer has, and the electrical safety program, how do they execute that energized electrical work task. And 70 and Z462 as a priority outline that you should have a documented electrical safety program, and it should have content as outlined in 70 and beyond that, based on occupational health and safety management system standards. Then we'll get into a brief review of the changes and updates. Again, this is a part one webinar. Part two will delve into details of the risk assessment procedure, which over the last 3 years with the 2015 editions of 70 and Z462 and the experience I've had in industry has not been well understood. Again, this is the requirement for the risk assessment procedure. Again, I won't be delving into details in this webinar, but I would encourage you to watch your email for part two of this webinar coming sometime in the next month to 2 months. So that'll be part two, and we'll again announce a date for that in a future email. Then Q&As at the end of the webinar today as well. So in the GoToWebinar control panel, there is a box for entering questions. So please, as I go through the webinar, put your questions into that questions box in the GoToWebinar control panel. And at the end of the webinar, I'll endeavor to answer as many questions as I can. We will be emailing out a link to this webinar to everyone that's logged in. And again, if you have any questions after the webinar, you can get in touch with me. So Danatec's electrical safety program workflow process flowchart, as I said, energized electrical work is managed and controlled in a work site. And there's either a work order system or some informal process. And a qualified electrical worker, as I discuss this work or this qualified person, I use qualified electrical worker. There's multiple trades and roles that can fulfill that requirement. They are assigned a job, and that job includes energized electrical work tasks, discrete energized electrical work tasks that may expose them to arc flash and shock. And as far as how they manage the processing of that work, there's a workflow process that I've identified, and what you're going to see is the workflow process specific to the 2018 NFPA 70E and Z462, as well as occupational health and safety management systems or work control systems for large industrial establishments. So again, we have a job assigned to a worker. If, for instance, motor's not running, and then there'll be discrete energized electrical work tasks related to the qualified electrical worker troubleshooting that motor and, again, getting it back into service. So again, this is a flow chart. It's a visual communication tool that I use to describe to clients and qualified electrical workers the processing of energized electrical work. So there's the flow chart in its entirety, and then I've just blown it up and divided it into 3 pieces so that you can see it on the screen. So basically, we get a work order assigned to a worker to complete a job, again, formal or informal, and that's step 1. Step 2 is something that has come up over the years, which is managing temporary power. So TPC stands for, is a temporary power certificate required? The answer is yes or no. Now that relates to, again, construction and installation of large generation and power distribution on a temporary basis. If the work order doesn't require that, the worker goes to step 4, and then they review the assigned job. They determine that it includes discrete energized electrical work tasks that may expose them to arc flash and shock. And if it does, then they have to proceed to process the requirements of their company's electrical safety program, which is step 5, the risk assessment procedure, again, as an overarching requirement that the electrical safety program should document. If the job doesn't include energized electrical work tasks, then the company's electrical safety program and the requirements of NFPA 70E and Z462 don't apply. Under step 5, you'll read that it says qualified electrical worker to firm the company's electrical safety program requirements for individual work tasks. And then with respect to the 2018 edition of 70E and Z462, one of the tables in the arc flash PP category table method has been removed from that process, and it has been moved into the arc flash risk assessment requirement. In Z462, it's table 2. And it provides a generic energized electrical work task list that can now be used independently of either method of determining additional protective measures. And the company has and should have a documented risk assessment procedure, including a risk register table. And again, this will be covered in more detail in part 2 of this webinar with respect to the risk assessment procedure. So the risk assessment procedure requires that each energized electrical work task is individually risked with an initial or an inherent risk level and a residual risk level, and that is then documented in what I've defined as a risk register table. And when you're completing the risk assessment, and this is documented in 70 and Z462, you've got to use the hierarchy of risk control methods to achieve a residual risk level. And those are 6 risk control methods with a top-down requirement where all of those should be applied to the individual work task to reduce the inherent or initial risk level to achieve an acceptable residual risk level. And then in the 70E and Z462 standards, it now talks about additional protective measures. So your arc flash risk assessment and your shock risk assessment, which the qualified electrical worker will complete and document at the work location, will define additional protective measures, which is boundaries and PPE. Now, those additional protective measures, as far as risk, only have a positive impact on the severity of injury or damage to health. So again, just a little bit of a sidebar on risk assessment. I'm not going to go into too much detail, but step 5, with respect to this qualified electrical worker processing a job and doing energized electrical work, requires that they document their risk assessment procedure, which will include an arc flash risk assessment and a shock risk assessment. Now, step 6 is the energized electrical work permit requirement within Z462 and 70E. So this is a separate requirement from completing the risk assessment procedure. The qualified electrical worker has to determine if the discrete energized electrical work task requires an energized electrical work permit or not. They need to process the permit. Now, I've got another acronym on the screen, which is Energized Electrical Job Risk Assessment Form. And that form is a custom form that Danatec has developed in the electrical safety program that we offer to clients. That is a field-based equivalent of a field-level hazard assessment document. And it allows the qualified electrical worker to document their arc flash and shock risk assessments, and also validate the application of the hierarchy of risk control methods that they personally will implement so that their personal residual risk level is acceptable. In the case of the electrical safety program that Danatec has available, that's a lower medium risk work task. In step 8 for large industrials, there may be a safe work permit that has to be issued from the control room, the operators of the facility. Again, that would be for large industrial sites. If your site doesn't have a requirement, then obviously step 8 would be removed from the workflow process flowchart. At step 9, the qualified electrical worker would proceed to the work location. They would complete a job safety plan and job briefing. Job safety planning was a new requirement in the 2018 edition of 70E and Z462. And in turn, they would have a separate job briefing if there's more than one worker. And again, this energized electrical job risk assessment form that Danatec has available in our licensed electrical safety program would be used by the qualified electrical worker to implement the job safety plan and to document the job briefing. In step 10, the qualified electrical worker or electrical workers, if there's more than one, would establish an electrical work zone with red danger tape or some other form of barricading to keep, again, unqualified, unprotected workers out of the area where there may be an arc flash or there is a shock exposure depending on the work task. So again, electrical work zone would be established at the arc flash boundary or the limit approach boundary for shock, which is ever further away. Step 11, the qualified electrical worker would perform the work task. Obviously, they would have to don their PPE and pre-use check and inspect their PPE before they don it. And then they would wear the appropriate PPE when they're inside the boundaries and exposed to arc flash and shock to execute the individual energized electrical work tasks. They would use an electrical safe work procedure as required at this point to execute the work task. After completing the work task, they would doff the PPE. And I've included step 12, 13, and 14 in this workflow process, which is completing a post-job analysis. So were there anything that went wrong? Is there a requirement for management of change to revise procedures, one-line diagrams, problems with PPE? Again, the qualified electrical worker would determine this in the post-job analysis, follow up appropriately with inside the company related to management of change or discussing any issues with their supervisor. And in step 15, the qualified electrical worker would take their work order, what I call work package, and they would submit any of the forms that require review by the supervisor or retention, and then they would get the next work order. So just a little sidebar of introducing this workflow process, again, on how to execute an energized electrical work task. Now moving into the 2018 editions, the good news is Z462 2018 edition published this Monday, January 8th, and it is available in PDF at this point in time. NFPA 70 published obviously last year in October 2017, but the good news is Z462 published on Monday this week. So if you don't have a copy, I'd encourage you to go to CSA's website. You can download a PDF of the 2018 edition of Z462 today. Again, hard copy of Z462 will be available in the next 2 to 3 weeks. So for Canada, that's good news. We're finally here, 4th edition of Z462. Now the electrical safety program requirements. So now this is more of a generic discussion of the electrical safety program requirements that NFPA 70E and Z462 outline. Now what they say is that your company shall have an electrical safety program. It needs to be documented and implemented as a component of your company's overall occupational health and safety management system. This is not well understood in industry about this requirement for a program, or if companies have developed a program, it's not a compliant program. And again, they don't have all of the requirements that I'm going to outline in the slides that are coming. So your electrical safety program shall include a risk assessment procedure. That is also in 70 and Z462. So you have to identify the risk assessment procedure. then in turn the risk assessment procedure shall be documented for, again, energized electrical work tasks. So I often get asked, what's a compliant electrical safety program? What does 70E and Z462 in this case tell us that an electrical safety program should include for content? So the content in 70E and Z462 as far as electrical safety program requirements isn't 100% complete, but it's pretty good. There is a definition for electrical safety program in 70E and Z462. I think this was added in 2018 edition. A documented system consisting of electrical safety principles, policies, procedures, and processes that directs activities appropriate for the risk associated with electrical hazards. So again, that is a great definition of an electrical safety program. The workflow process flowchart that I just illustrated and discussed with you is an example of a document that's a component of the electrical safety program that, again, that Danatec has developed. So right out of Z462, and as I go through this webinar, I'm going to be showing the clause numbers from Z462. The 70 article numbers will be obviously different, but the standards are still technically harmonized. All right, so I can't, again, as far as just efficiency, I didn't include both the article numbers and the clause numbers. What you're seeing on the screen today will be the CSA Z462 clause numbers, but technically harmonized, so the text and the content that I'm discussing is the same in NFPA 70 as it is in Z462. So this is interesting. When I was reviewing the standards again about responsibility, so the employer shall have the following responsibilities: establish, document, and implement the safety-related work practices and procedures required by the standard, provide workers with training in the employer's safety-related work practices and procedures. Now that's interesting, because that statement, clause 4.1, 3.12, would say that if your company has an electrical safety program, you need to make sure that you've trained your workers on the requirements of your specific electrical safety program, and that would include any of the overall occupational health and safety management system requirements, like, for instance, filling out a field level hazard assessment. And then worker responsibility: the worker shall comply with the safety-related work practices and procedures provided by the employer. And that's quite important, because once an electrical safety program is developed, the workers have been trained on its requirements, then you need to be able to enforce that those requirements are being complied with. So again, progressive discipline related to policies and practices is a key component of your electrical safety program. Without that, you can't, well, your program's not going to be effective. If there's no repercussions when the workers aren't wearing rubber insulating gloves or other protectors, then you will fail. So you do have to communicate to your workers that the policies are enforceable, and there will be progressive discipline. So your electrical safety program, and what's going to come in the next several slides, just a laundry list. Again, 70E and Z462 do not have the complete framework of an electrical safety program identified, but it's pretty darn good. So the electrical safety program shall direct activity appropriate to the risk associated with electrical hazards. So in the 2015 editions of 70 and Z462, we moved from hazard to risk-based language, and that hasn't gone away. In fact, the risk content in the standards in 2018 has just increased, which means clarifying arc flash risk assessment and shock risk assessment as an example. So your electrical safety program has to direct activity and manage the risk associated with electrical hazards. It shall be implemented as part of an employer's overall occupational health and safety management system. So my expectations when I talk to a client are that they have some form of an overall OHSMS. I do review it because I'm looking for some key requirements within it that the electrical safety program needs to align with and ensure that it doesn't compromise. The program, and this is a new requirement in the 2018 editions, needs to ensure that it identifies inspection of electrical equipment and systems. So approved equipment installed to the jurisdiction having authorities requirements for the National Electrical Code or the Canadian Electrical Code Part 1. So again, there's a new article or clause in Z462 that says your electrical safety program should address that requirement. The program should include elements of condition of maintenance. Now, condition of maintenance, again, this is an element of risk related to probability, related to likelihood of occurrence, which has been further emphasized with the new Table 2 or the new Table 130.5C in NFPA 70E. This work task table, it uses condition of maintenance and then implies likelihood of occurrence of an arcing fault or an arc flash the previous use of that table in the arc flash PP category table method would imply arc flash PP required. Well, this table again was removed from the arc flash PP category table method and made a separate table to be used under the arc flash risk assessment requirement. It is again a risk-based table, condition of maintenance, now likely of occurrence of an arcing fault in an arc flash, and I'll discuss that in a slide coming up in a little more detail. So the electrical safety program should provide awareness to workers, and it's both in electrical workers and non-electrical workers. So your electrical safety program, as the employer or the host employer, has to address not only electrical workers, but non-electrical workers. And again, non-electrical workers are predominantly exposed to the shock hazard with their use of portable cord and plug connected electrical equipment and the need to identify a GFCI to reduce the risk of shock. Your electrical safety program should identify principles which it's based on. There should be controls by which it's measured and monitored. So again, we need to have, in this measuring and monitoring means that you need to audit your program. So your electrical safety program should have a component of internal and external electrical safety auditing. Your program should identify the need for procedures. Again, that's an element of risk reduction, using a procedure to try and manage human error. And I'll discuss human error coming up as well, that's been emphasized in the 2018 edition of NFPA 70E and Z462. In fact, in 70E, there's a whole new annex on human performance that we had included in Z462. So I encourage you to take a look at the human performance annex in NFPA 70E 2018, because that annex did not exist in the 2015 edition. So a lot more information on human performance. Again, a key element of likelihood of occurrence of an arcing fault, an arc flash, and shock exposure is the worker's human performance. That is a separate topic from the qualified worker and the competent worker. So qualified and competent worker is one element of likelihood of occurrence, but the other element is human performance and managing the potential for human error. The electrical safety program shall, as I mentioned earlier, have a documented risk assessment procedure that applies the hierarchy of risk control methods to reduce risk, and it should consider human error. So the human error component of the risk assessment procedure in 70E and Z462 is new in the 2018 editions, and the hierarchy of risk control methods were a note, and they have now been moved into the core article or clause. So it'll be mandatory that you shall use the hierarchy of risk controls, and there's 6 of them, top down, right? Energized, substitution, engineering safety by design, warning signs and barricading, administrative controls, and electrical specific PP tools and equipment and their proper care, use, and maintenance as last. It's a top-down list. It's not bottom-up. Unfortunately, the history here is that industry has been doing a bottom-up approach to the hierarchy of risk control methods, and that needs to stop. So we apply the hierarchy of risk control methods in implementing the overall energized electrical work task risk assessment procedure, again, to drive down the initial risk level so that our residual risk level is acceptable or as low as reasonably practicable. There's risk language that was in the 015 standards that is now still in the 018, and there's more of a requirement for you to understand this risk language and be able to apply, again, this overall risk assessment procedure. The electrical safety program, identify worker in charge, and at, again, the worksite location in the workflow process flowchart, a job safety plan should have been completed. And in fact, at the worksite location, the job safety plan will be implemented. And if there's more than one worker, a job briefing will occur. And again, you need to document the job safety plan and you need to document the job briefing. The electrical safety program should include requirements for incident investigation to closure. So I find that this is not effectively managed. Companies do have overall incident management systems and their overall OHSMS systems, but what they lack is they lack any electrical hazard content in the overall IMS. I see this over and over again. So what I've implemented in the Danatec electrical safety program is an incident investigation form for electrical incidents specifically. And that can be used with the overall incident investigation form or a software tool, and it ensures that specific electrical information is collected from the incident scene. This is critical to doing a root cause analysis of the incident, is that information is collected at the point that the incident occurs. So The electrical safety program, I mentioned audit, so it should have two levels of audit. It should have the electrical safety program being audited and fieldwork auditing. Fieldwork auditing, in my opinion, should be implemented by the supervisor as a normal course of their job. So I call it supervisory level audit, daily, weekly, monthly. And then the electrical safety program itself has to have a system audit completed for it. And again, this is not well understood, and this has not been implemented. In the 10 years that I've been doing independent electrical safety consulting, I don't think I've seen one client do an internal electrical safety audit until I consulted with them and advised them they needed to complete it. And then I gave them a tool to implement the internal electrical safety audit. So supervisory level audit should have been happening all along. Electrical safety program system audit has not been happening, unfortunately. Now, in the 018 editions, a 70 and Z462 related to establishing an electrical safe work condition, the lockout requirements were moved forward in the standards and embedded in Article 110 and Clause 4. So a separate lockout program, and this is another good point, that the electrical safety program is not a lockout tagout program. There should be a separate lockout tagout program as part of the overall occupational health and safety management system. So the electrical safety program will use that lockout tagout program in implementing the requirements of establishing an electrical safe work condition. Some training requirements, and on this note, the lockout tagout requirements for training and auditing have moved into, again, Clause 4.1 and Article 110. So your electrical safety program should address training. Obviously, there's still a 3-year frequency, but the training now should, and it's emphasized, include electrical safety training, lockout training, and first aid and emergency release of shock victim training. So there's 3 elements of the training. Electrical safety training, that's standard 70E Z462 training. Actually, within that training, your workers should be receiving training on emergency release of a shock victim, but separately outside of that training, formal lockout tagout training. And again, contact release training as part of the electrical emergency response training component of the overall electrical safety training. So the electrical safety program has to address test instruments and equipment. Again, what it is, approvals. Again, that should be identified in your program. Your electrical safety program should address portable cord and plug connected electrical equipment for electrical workers and non-electrical workers. But here again, the majority of the users, or the volume of users there, is non-electrical workers. Ground fault circuit interrupters shall be provided. In the US, you can use an assured equipment grounding conductor program. It's allowed by OSHA, but I don't recommend it. GFCI shall be the preferred method. Your electrical safety program, again, has to address establishing an electrical safe work condition. That's a key and core requirement of 70E and Z462. Now, that process has been renamed to a process for establishing and verifying an electrically safe work condition. So that's a new title for that. There's now 8 steps instead of 6. And it also now documents that for greater than 1,000 volts AC, proximity non-contact test instruments are acceptable for use. And there's been one other element that's been very controversial over the years that now has been added as well. Adequately rated permanently mounted test devices are permitted or allowed, but they have to be approved, and there's quite stringent approvals. So there has been a product in industry used that would not have met these requirements. There is now a product from a different vendor that's available that meets those requirements. Again, so it now does identify that you can use those. Personally, I still believe that for low voltage, the qualified electrical worker should use a contact tester over any indicating lamp on the door. And then temporary protective grounding. If you do have high voltage systems, your electrical safety program should address temporary protective grounding. Obviously, your electrical safety program, if we can't establish an electrically safe work condition, should address work involving electrical hazards. So again, justification for energized electrical work if you can't establish an electrically safe work condition. Additional hazards, increased risk, or infeasibility are still the justifications that are listed. A key change for Canada is CSA Z462 now moved the 50 volt threshold down to 30 volts. Again, this aligns with the Canadian Electrical Part 1 definition for extra low voltage. Extra low voltage. In the US, it's still a 50 volt threshold. So that's now another deviation where we aren't technically harmonized. Canada Z462 is now a 30 volt threshold. It retains a 50 volt threshold with NFPA 70E. Your electrical safety program, and the next bullet says normal operating condition. This was in the 2015 editions as a clause in an article, and it's very important. And I have conversations quite often over the last several years since this concept of normal operating condition was identified. I think I've always talked to clients about normal operating condition, but the controversy is, well, how do we determine normal and abnormal operating conditions? And basically, we can use the definition information in 70 and Z462, and part of the electrical safety program should be validating that your company has a normal operating condition right now for your energized electrical equipment. In fact, that is our starting point. We should start by assuming that we have a normal operating condition, and then through review and validation, determine if there are abnormal conditions. And this is part of the overall risk assessment procedure, again, that I'll discuss in part 2 of this in a future webinar. Of course, your electrical safety program should identify the energized electrical work permit. I had that in the workflow process flowchart. Again, the requirements for it should be documented in your electrical safety program. When is the permit needed? When is it not needed? One thing that I do work with clients is using an annual energized electrical work permit concept. So again, the electrical safety program, this is the real power for the owner of the electrical equipment or the host employer. The power of the electrical safety program is you can take the 70 and Z462 standards and you can embellish and expand upon their requirements to demonstrate implementation in the field in a practical and reasonable approach. So an annual energized electrical work permit, if you're interested in discussing that concept, get in touch with me and I'll explain it. Now, the key requirements within 70 and Z462 underneath the risk assessment procedure. So the risk assessment procedure is a separate process from completing a shock risk assessment and an arc flash risk assessment. That's also confused in industry, and I think that some of the training that's available out there, the generic training, though the training doesn't explain this correctly. So the risk assessment procedure is an overarching risk assessment process. There's 2 separate risk assessments that will feed into the overall risk assessment procedure to address severity or potential for injury or damage to health, and that's the shock risk assessment and the arc flash risk assessment. Your electrical safety program should explain this and explain how these 2 risk assessments should be implemented in the field. Now, what happened in 2018 is the language was changed within the clauses or articles to make sure that these are independent risk assessments performed underneath the overall risk assessment procedure. So again, you'll have to identify that the individual work task has a shock exposure or arc flash. You have to assess risk, and then you have to apply, again, the hierarchy of risk control methods, which in the case of these 2 risk assessments is determining what's called additional protective measures. That's new language in the 2018 editions. So these arc flash and shock risk assessments for an individual discrete work task require that you identify additional protective measures, and that'll include identifying the boundaries and the PP to be used when and if the qualified electrical work is exposed to arc flash and shock when they're inside the boundary and performing the discrete energized electrical work task. There's 2 methods to determine additional protective measures. Arc flash incident energy analysis studies performed by a PE or a P.Eng, or the arc flash PP category table method. So again, this is new information I'm communicating to you right now. The biggest change, in my opinion, was the electrical safety program beefing up its requirements and the risk assessment procedure, and then the arc flash risk assessment, and then the shock risk assessment. But under the arc flash risk assessment, that's where the significant changes are, and it's a completely different process than probably what you're implementing or what you've been trained on previously based on the 2015 edition training. So significant updates here, and these 2 individual risk assessments are now completely aligned with what would be called risk assessments in reality. So more discussion there, and I'll cover that in the part 2 webinar to be scheduled. Now, equipment labeling, this is a significant change, and I've been talking to clients, large industrials, about this for quite some time, that you don't have to install equipment labels as long as you provide the arc flash hazard data to the qualified electrical worker. So now this is documented for large industrial supervised sites in 70 and Z462. This is a significant change in the 2018 editions, is that host employers, large companies, industrial, commercial, institutional, can provide the arc flash hazard data with results tables directly from the engineering report. They could embed that information from the engineering report into their computerized maintenance management system against an asset record, an electrical asset record, and then work orders could be issued with the arc flash incident energy, the arc flash boundary, and the working distance included with the work order printed out. You could also use a generic arc flash single line diagram. And then what you end up installing is a generic equipment label, because you still have to comply with the minimum arc flash label or the minimum arc flash and shock label for the NEC or the CEC. And I'm going to show you an example of the label, the results table and arc flash single line here on the next slide. So your electrical safety program, as far as policies and practices, it has to document that your company is going to address alertness, scope changes, blind reaching, illumination, no jury policy, confined or enclosed workspaces, clear spaces. That has to be in your electrical safety program. Now here's an example under the new labeling requirements. That's a generic warning label on the left. This could be you print, like for a large industrial site, you print 1,000 of these and you put these over top of your existing arc flash and shock equipment labels, and then you save a ton of money going forward. The equipment labeling has become its own little, let's call it, cash generating business for the label printers. And now we can move beyond that, and we can also get rid of any errors that have been translated to these labels. And I've seen many labels performing external electrical safety audits in the last 12 months, where the labels that were installed are non-compliant to start out with. So you avoid any issues with labels because you put this generic warning label on equipment. And again, as you can see, it says refer to company electrical maintenance department, arc flash incident energy study results table, or CMMS asset record for arc flash and shock data. A phone number is indicated, and the building or office location on the site where someone that's reading this may want to go to talk to someone. On the right is an example of an arc flash single line. So this is just an option. At a minimum, you'd put this table on your equipment, and you'd have the results table from an arc flash incident energy analysis study. If you wanted to go an extra mile, you could create an arc flash single line diagram that's indicated on the right. Obviously, what you see is pretty busy, requires some explanation, but that is a working example of an arc flash single line diagram. So the results tables, if you've had a study completed for your facility, or you're an engineer that completes these studies, this is directly right out of ETAP, SCAM, or Easy Power. And why not just give this information to the qualified electrical worker directly? We eliminate any error that's pushed from these to the labels. And this is what I'm encouraging, again, large industrials now on a go-forward basis, is make these results tables available to your qualified electrical workers. The detailed report should be in the maintenance shop anyways, and then you can pull these tables out, you can laminate them, you can have them on the shop table, or give them to each individual worker, or post them in your electrical rooms. So this, again, is a key and significant change, which should be documented in the company's electrical safety program. Document that generic warning label, and whether you're going to use an arc flash single line or not, that would be bonus information. But at a minimum, you would give the results table directly to the qualified electrical worker. And again, the information they need is the arc flash boundary, the working distance, and the incident energy. And they can read it right off the results table against the bus name, the equipment ID, and the protected device upstream of their work task location that incident energy value is based on. So the electrical safety program continuing should document in a policy practice section housekeeping requirements, anticipating failure, reclosing after protected device operation. Again, that's overcurrents and who can actually reset those should be documented. Lookalike equipment, alerting techniques. Again, that's the electrical work zone barricading is a method of, again, alerting non-electrical workers that they can't approach the energized electrical equipment, and in turn there should be some qualified electrical workers inside that barricading doing work. Overhead power lines should be documented. Now, overhead power lines, another area that needs focus for companies that have large distributed sites and utility services. This statistically is where the shocks and electrocutions have been and are and will be, unfortunately. So we need a lot more attention on overhead power line safety and overhead power line management. I encourage that a company's electrical safety program should have a power line encroachment authorization permit that has to be filled out before any worker encroaches inside 7 meters to overhead power lines. Your electrical safety program should include PP tools and equipment, detailed information on spec, procurement, a whole laundry list of requirements here that I've been communicating for quite some time. When I perform external electrical safety audits, I still see a lot of fundamental problems there. So, and again, one key thing I've noted here that has been one of my one of the things I've sort of tried to focus on is getting everybody away from the fact that ARC-rated clothing is not defined by a hazard risk category or an ARC/PP category. ARC-rated clothing is tested and has been given an ARC thermal performance value. That is the technical, again, rating of the PP is the ARC thermal performance value in calories per centimeter squared. ARC-rated clothing should not be in normal discussions, HRC2, HRC4, ARC/P category 2 or 4. That should not be the normal context of discussing ARC-rated clothing. It is what ATPV do you have on right now? Well, I got 8.7. What ATP arc flash chute? Well, I've got a 140 calorie per centimeter squared arc flash chute on. That's the ATPV value of the arc flash chute? Yes. And that performance at 140 cals is going to protect to the 50% probability of the onset of secondary burn? And the answer is yes. That's how we should discuss ARC/PP. Now, again, the differences document in the GoToMeeting control panel under handouts, you can download this document. This is a more detailed review of all of the changes, again, specific to Z462. But again, the articles and the clauses, 95% of it's technically harmonized. So again, when it discusses something in this document, it applies to either 70 or Z462. I will be bringing this out for 70E sometime in the next several months. And again, I appreciate Jim Pollard with Unlimited PP for assisting me with reviewing and compiling this information. So again, please download the document. So the significant changes, I've discussed some of them already, but I'm going to just highlight, I think, the top 10 I've got listed here. So again, I'm presenting to you information with Z462 clause numbers, again, but they're the same technical requirements in 70E. As far as the risk assessment piece, in Canada, we have a risk assessment standard called CSA Z462. And there is more details in Z462 and 70E in Annex F. There's a very detailed risk assessment procedure in the 2015 editions of 70 and Z462 and Annex F that I encourage you, if you have never looked at it, to review it. That will be the context of the risk assessment procedure Part 2 webinar. And unfortunately, the current Annex Fs were completely rewritten, and they provide very, very high-level information on completing risk assessments. They don't give you a working process. They give you more of the philosophical risk assessment requirements, and then you have to develop and implement a detailed risk assessment process in order to implement the risk assessment procedure. Obviously, to energize as possible, that is the key requirement still in 70 and Z462. But the majority of the document is giving you tools when energized electrical work tasks are completed by qualified electrical workers. So the overall risk assessment procedure is the overall determination of a risk level for the work tasks that are being performed under a job. So and underneath that, the arc flash and shock risk assessments are separate, and they only, again, provide additional protective measures to lower the initial or inherent risk level when no arc flash or shock PP is worn to a residual risk level that will reduce the potential harm, or in the case of shock, eliminate the shock risk exposure with the application of rubber electrical protective equipment. So the key changes, so I think I do have the top 10 here. Again, I mentioned earlier that the low voltage threshold, unfortunately, will be different between the two standards. So it's now 30 volts for Canada. It remains as 50 volts for the USA. And then again, this was Z462 harmonizing with the Canadian Electrical Part 1 and the definitions of voltage and extra low voltage is 30 volts in CEC Part 1. Again, 70 stays at 50 volts. The risk assess procedure was modified. And again, what happened is it included now that human error shall be considered as a component of the overall risk assessment procedure, which impacts the likelihood of occurrence. And then the hierarchy of risk control methods shall be applied in the risk assessment procedure. And again, those are preventive and protective control methods. All of them shall be applied, and it should be a top-down approach as you perform your risk assessment. And basically, when you do risk assessments, you do iterations in applying the control methods. I recommend that you just do one iteration, you apply all of the hierarchy of risk control methods to achieve a residual risk level, in the case of how I discuss it, of low or medium risk. So again, those are new requirements, that these are mandatory requirements of the risk assessment procedure, again, in 70E or Z462. Job safety planning was added. Again, that again is, I think, another valuable addition, that you should have job safety planning that implies that you've got to basically follow the workflow process flow chart, actually, but then you want to identify the hazards. You want to make sure that arc flash and shock risk assessments are completed, implementation of the controls. You want to make sure that that process is planned out, and then that in fact is implemented by the worker in the field. The shock risk assessment, it was modified to make it a true risk assessment process, and the new language is the outcome will be additional protective measures, and it'll be boundaries, the limited or restricted approach boundaries, or shock PP tools and equipment will be the outcome of the shock risk assessment to mitigate exposure to shock to the worker, the qualified electrical worker. Now, item 5, this has been an ongoing effort, the 40 cal per centimeter squared myth. So the deletion of the notes from Z462 and 70E that implied that if the incident energy is greater than 40 cals, greater emphasis is required. There was never any substantiation to that note, and it's mentioned in Annex D. So it's been removed. Incident energy doesn't correlate to arc blast pressure. It never did. Again, I've been communicating this probably for 10 years. And again, it's been exacerbated by training, in my opinion, that has had fear-based information in it, or instructors that basically, because HRC4 says 40, it must be the cutoff, and that's never been true. There are arc flash suits available from Oberon Company, 106 calories per centimeter squared ATPV and 140 calories ATPV, and those suits can be used, especially when you do a risk assessment procedure and you do it properly. It will indicate that PP up to 140 cals can be used. So there's a 40 cal myth out there. It needs to go away, and it's going to be a challenge, and I'll be continuing to promote this in future webinars or in my presentations that I provide to industry at industry-related conferences and workshops. There's also a miscommunication of, separate sidebar here, about operating energized electrical equipment is inherently an arc flash risk, and it's not. So probably discuss that in more detail in the risk assessment procedure part 2 webinar. Again, this was also propagated by the software tools, including PP in the results tables. And unfortunately, they still do include PP in the results tables. So this is going to further exacerbate the issue for a host employer or a company that owns the power distribution equipment. So there's an ongoing effort here to get this 40 cal number removed from industry, that your risk assessment procedure, you're going to use PP up to 140 calories. Glad to talk about that offline. If you want to email me, we can have a conversation and I can follow up and give you more information on that. So the arc flash risk assessment, item 6, as I mentioned, it's been modified to make it a true risk assessment process. You determine additional protective measures for arc flash, which will be the arc flash boundary, work practices, and arc flash PP when you're inside the boundaries and exposed. What happened, and this I mentioned earlier, was the Z462 table 4A has been removed from the arc flash PP category table method, and it's now called table 2. It's independent, and it's embedded in the arc flash risk assessment clause. That is also now table 130.5C in NFPA 70E, that was again extracted from the arc flash category table method and moved forward into the arc flash risk assessment. And as you go through the arc flash risk assessment process of identifying if a worker will be exposed to an arcing fault in arc flash, assessing risk, and again applying the hierarchy of risk control methods, right, to reduce risk, you'll be doing that by identifying additional protective measures. And then the clause or article says that you can use this table as a starting point. It's a discrete list of energized electrical work tasks based on condition of maintenance. It then indicates likelihood of occurrence of an arcing fault or an arc flash as yes or no. Again, this is a significant process change related to the arc flash risk assessment. And again, I can't probably do it justice I probably will have more information on the risk assessment procedure part 2 webinar that'll be scheduled related to how to use this table in the arc flash risk assessment, and how this table can be used within your electrical safety program and the workflow process flowchart, where I indicated this table is referenced by the qualified electrical worker when they receive their work order to help them identify that the energized electrical work task or tasks required to complete the job will expose them to an arcing fault and arc flash risk as a likely occurrence, and separately they do an arc flash risk, a shock risk assessment. So there's just a snapshot of these two tables. The work tasks in the old tables from the arc flash P category table method have been resorted, and then they've been resorted under any equipment condition and likely of occurrence as yes or no. So any equipment condition, normal or abnormal conditions, and then likely of occurrence of an arcing fault or an arc flash, yes or no. So again, a lot more explanations required on how to use these tables in completing the overall risk assessment procedure and specifically the arc flash risk assessment. So I mentioned this earlier. No, I didn't. This is actually something different. So what also happened is, and it relates to this confusion on selecting arc flash PPE, where we had incident energy analysis studies being completed, and the reports came out listing an HRC number, and it never should have. That was, again, a technical error related to the engineer that completed those studies, because they never should have correlated HRCs to incident energy, because IEEE 1584 doesn't do that, and neither does 70E or Z462. So this was a change that was trying to fix this problem. What we now have is Z462 Table 3 and NFPA 70E Table 130.5G, personal protective equipment. Those tables are the same, and they were moved, extracted from Annex H, Table H2, and moved into the body of the standard. So now that you will use these tables, or you shall use these tables to determine additional protective measures related to incident energy analysis only. But when you use the table method, you can have a 2 arc rated level selection process. And most companies have procured 2 ATPV ratings of arc flash clothing, an everyday wear coverall or shirt or pant, or an arc flash suit. So you would have went down this path, but to ensure now on a go-forward basis that when incident energy analysis is completed, these tables were embedded right in the articles or clauses to say that you will select PPE when incident energy analysis is completed and have 2 choices, 1.2 to 12 calories or greater than 12 calories per centimeter squared. So this helps me because it further clarifies that incident energy analysis, the PP is determined by an ATPV value of clothing that's greater than or equal to the incident energy that was calculated and provided in the results table. So again, I recommend that companies clarify this process. And yes, you have two selections, but then I've indicated below that we want to move away from the 40 cal. I encourage your company to purchase 67 calories, 106 calories, or 140 cal arc flash suits and have those available to your workers. And you could have 2 choices still. You could have 67 calories and 140 calories, but move away from the 40 calorie. That number we need to rub it out from people's heads that is not the stop point for incident energy. And then one thing I'm going to highlight is over the last year and a half, about a year and a half ago, Oberon Company brought out a true color gray lens for their arc-rated face shields and arc flash suit hoods. This is a game changer a year and a half ago. And I don't think a lot of companies knew that it was available a year and a half ago. Oberon Company has been actively marketing it, but this is a game changer now when you select your PP. So basically that's an MCC starter bucket, a qualified electrical worker, and you can see the light gray tint on the arc-rated face shield. Well, what happens is there is no wire color discoloration. There's no visual light transmission degradation. And you'll also see a lamp on that shield and the difference that the lamp makes. So when I work with clients, I encourage them to review what arc-rated face shields they purchased. If they have Oberons or Honeywell Salisbury's, they should upgrade to this true color gray lens technology and ensure that you have the LED lamp. Look at the difference on the lighting there. It's unbelievable, especially in MCC starter buckets or other enclosed equipment. So then again, the PP again for incident energy analysis study shall have 2 choices, 1.2 to 12 calories or greater than 12 calories. 2 selections that are available to the qualified electrical worker, 2 different arc ratings your company should procure and have available to the workers. So the arc flash P category table method, this is where I advised you again that the one of the tables was extracted and moved, and that's table 2, or the equivalent table in 70E, and these table numbers have been renumbered. So that technically the table content is the same. The process for using the ARC/P category table method is the same, but now the table numbers have changed, and that'll be confusing for people. And again, it's table 6A, 6B, or 6C for Z462. It's table 130.7C15A, B, and C for 70E. Technically, no changes. There is one significant note change, is that it now lists in table 6B, or table 130.7C15B, a generic list of typical protective device fault clearing times. And that information has actually previously been documented in IEEE 1584, but now it is embedded at the bottom of this table, so that when you're using this table, you can look to some generic information for typical protective device fault clearing times. I mentioned item 9 already with equipment labeling and the use of results tables, or an arc flash single line diagram, or embedding information for arc flash in synergy analysis and work orders. So just bringing things to a close. Again, meant to try and keep this short and not run over. And I'm looking at the clock and I'm right about on time. Significant changes. There is the document that you can download from the handouts, menu item on the GoToWebinar. I encourage you to get a copy of Z462 that just published on Monday. For those of you from the States, you should probably have a copy of 70E. I want to thank you for listening. Key message here, you should have an electrical safety program. If you don't have one, get in touch with me. Danatec can help you develop an electrical safety program and implement it. It is the key to solving this problem, is through developing, implementing, and auditing an electrical safety program. And every 3 years, when the standard cycle, you update it with these changes, and then you train your workers on the changes of your electrical safety program, and in turn the changes from 70 and Z462. So you do need to train every 3 years at a minimum, generically on 70 and Z462's requirements. And then separately, you need to do electrical safety program rollout training for your company. So I'll try and take some questions here. I noticed there are a few questions. Let's just see here. I missed one of the questions. Again, I haven't been looking at the questions until now. External established. Shall an external body review and audit and establish an electrical safety program? So within occupational health and safety standards and processes, an external electrical safety audit by an independent, unbiased auditor should be completed for your electrical safety program at least every 3 years. And another request to look back at the flow chart. Now remember, this is being recorded, and this recording will be emailed to you. So you can review the recording offline and take a look at the workflow process flow chart. If you are interested in discussing the workflow process flow chart or receiving a PDF of it, drop me an email. My email address is at the bottom of the slide, tbecker@danatec.com. And again, the workflow process flow charts come up again. And unfortunately, this will only be sent out in a recordable recordable MP4 file. So I'm just going to open it up for any questions to be entered in the questions section of the GoToWebinar control panel. I'll just wait here. Again, if there's any questions, please type them in at this point in time. I'll answer them. I'll stay online here for the next several minutes if any additional questions come in. Again, this webinar is being recorded and will be emailed to you for review offline. And if you do have any questions, please drop me an email at tbecker@danatec.com, and I will get back to you. Again, this is part 1. Part 2 of this webinar will review the risk assessment procedure in more detail, including the shock risk assessment requirement and the new updated arc flash risk assessment requirement. Again, I cannot emphasize too much that the arc flash risk assessment requirement in the 2018 edition of the standards is significantly different. So please make sure you pay attention to that. Make sure you read it in 70 and Z462. And if you need clarity, get in touch with me. So I'm looking at the clock. It is now 10 a.m. Mountain Standard Time. There's no additional questions coming in. I want to thank you again for listening in today. Hopefully you have picked up some new information or validated some information that you are implementing at your company. I again want to emphasize that the key short and long term has always been developing, implementing, and auditing an electrical safety program to have sustainable and measurable results in electrical safety, applying the requirements of NFPA 70E or Z462 as due diligence to OSHA or OH&S regulations in Canada. Again, thank you for attending the webinar. Have a great day. Bye.